Hello everyone, welcome again in Eng-Man YouTube channel. So again, we will continue our learning on reservoir simulation using tNavigator software, and we will use sample case from tNavigator. We can learn a lot from those cases like the one we have right now. So in this case, we will perform alternating water and injection gas to improve oil recovery, and we will use CO2 as the injected gas. And later on, we will expand the case with CO2 dissolution. So you can also connect it with CCUS topic, carbon capture, utilization, and storage. Okay, where in this case, by dissolving the CO2 into the brine, sort of we are storing or sequestering the CO2. Okay, so first we will start by introducing the model. We start with initial properties, the size of block X in X direction, Y direction, Z direction. The depth, so we are located at this depth, around 6,000 feet. This is the top, net to gross, okay, net to gross of 1 throughout the reservoir, so it's good. Porosity, we have homogeneous reservoir from porosity point of view, but permeability varies a little bit. Not a little bit, but yeah, we have heterogeneous permeability, X direction, Y direction the same, and Z direction. And as you can see, yeah, maybe you can, relate the permeability in Z direction to the permeability in X direction. Because usually permeability in Y or Z direction, I mean, is a fraction of permeability in X or Y direction. So vertical permeability is usually a fraction of the horizontal permeability. Okay, so that's for the initial, that's the main thing. And as usual, we can expand the file here. So click on file, check the master data, and I will go through, I will show you the keywords, especially the most important ones. Okay, run spec as usual, tNav control, model E3. So you can relate the E3 with Eclipse software for simulation as well. And when we use E3, we use that for compositional modeling. Okay, and this is the title where we will call this topic water alternating gas injection using CO2, the injected gas. tNav control smooth RP, so we will use smoothing for the relative permeability, but actually it's not the most important thing here. And dimensions, this is important. So 9, 36, and 40. So basically we have 9 blocks in X direction, 36 in Y direction, and 40 in Z direction. And you can count it. So first we check X direction. So it's like this. And you can count it with me. In X direction, right, we will have 9 blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 36, you can count from the left side to the right side, and you will count as many as 36 grids. And in Z direction, you will have 40 blocks from the top down to the bottom. Okay, so that's what dimensions here means. And field, we will use field unit. We are going to use water, and this is the dimension for the data for the equalization. Okay, and if you check with properties equilibrium, we only have one here, one package of equilibration or equilibrium. Okay, and well dims, this is the setting for the dimensional for well data. And n scale, so yeah, I used this, dash, two dashes, so it means that we will not use this. Okay, that's not really important in this case. But basically, n scale means that we will use n scaling for the relative permeability. Nadir, it means that the scaling will not be based on any direction, and reverse means it is reversible. Okay, and comps, we will use 5 components in our compositional modeling, and you can add, right now you can check it by opening these components properties. Okay, 5 components: CO2, C1, N2, C2, C3, C4, C6, and C7 to C12 plus. Okay, so of course you need to do PVT analysis, PVT matching, PVT modeling, PVT lumping before you use the fluid, the generated fluid, the simulated fluid into the simulation, into the reservoir simulation. Okay, but again, we will use what is provided by the tNavigator in the form of example case, and that's it. We have 5 components. Okay, Univout, it's about, saving the calculation results as E1 or E3 binary files. So E1 means black oil modeling, E3 compositional modeling, referring to the term from Eclipse. Okay, and Univout also sets mode of the output, okay, for restart and summary files. But basically, it's about saving the result, and you can use this keyword. Okay, and then start of the simulation, June 1st, 1999, and then the RACDIMS. So RACDIMS is also, it's like WELDIMS, TAPDIMS. It's basically, about the region, the dimensional setting for the region, okay? And then the grid section. So whatever we have in our grid, we will take the data from this file. Includes grid.inc. .inc mean include. So we can check what we have inside the grid. So here we have, the initial, all of these data are taken from the grid file. So let's check it. Grid, this one. Okay,